Today's problem was submitted by a viewer, and it says, solve the equation log base x of alpha plus log base ax of alpha squared plus log base ax squared of alpha cubed is equal to 0, where a is greater than 0 and alpha is greater than 0. And I guess they want us to solve for x in terms of a and alpha and simplify as far as possible. Okay, we're solving for x. So log base x of alpha plus log base ax of alpha squared plus log base ax squared of alpha cubed is equal to 0. I'm not sure where the best place to start is exactly. You know, I could of course just write out by the definition of logarithms what, this is log alpha divided by log x and so on. And maybe we get some kind of simplification there. But I'm not really sure where things will go. Let's see what happens. There's more laws of logarithm stuff we can do, right? We have, this is log a plus log x. That's log a plus 2 log x. But we can cancel log alpha from everything. If I just copy this and put a 2 here and a 3 here like that, it says that alpha is greater than 0. So these logarithms are all defined. I guess I should assume that alpha is not equal to 1. Alpha equals 1 makes this trivial, right? The equation is automatically satisfied. So we assume alpha is not equal to 1. Then we have 1 over log x plus 2 over log ax plus 3 over log ax squared is equal to 0. Should we multiply through and simplify the denominator? So we write things like this. And now maybe I'm thinking using laws of logarithms to simplify all these and expand, and we might get a quadratic some kind of quadratic term for log x. Okay, so let's say capital A is equal to log of A and y is equal to log of x. Then I have a plus y times a plus 2y plus 2 y a plus 2y plus 3 y a plus y equals 0. So this is quadratic with respect to y, although it will take some simplification. Let's just expand and solve for y. Okay, so y squared, I have 1, 2, 6, 7, 8, 9. And linear in y, I have 3ay plus 5, 6, 7, 8. And then for the constant term, I think it's just this one, a squared. Okay, so y is equal to -8 plus or minus the square root of 64 minus 4 times 9 divided by 18. Oh, hold on, no, there's a's all over the place. What am I doing? Y is equal to -8a plus or minus the square root of 64a squared minus 4a squared times 9 divided by 18. Um, 64 minus 36 a don't know that a is well, it should be fine. We're 18. 64 minus 36. 34 minus 6. So what, 28? Two root 7 times a over 18. So I have y is equal to -4a plus or minus root 7a over 18. I don't think there's anything we can say about y being, about this number being positive. I mean, we have a base. X appears within the base of a logarithm. That doesn't mean I mean, I guess it means we should assume x is at least positive, right? But that says nothing about y. Oh, sorry, this should be divided by 9. So I have log of x is equal to -4 plus or minus root 7 log of a divided by 9. So does this say x is equal to a, the power of -4 plus or minus root 7 over 9? I mean, that's what I get just following the algebra, right? I don't see why. So if a is positive, we're given that a is positive. This says that then x is positive regardless of what that number is, right? I don't care if that number is positive or negative, although it'll always be negative, won't it? Is there a way for us to check this? I mean, I think I don't think there's any individual step here that I was that strikes me as something that could be very wrong. Right, this is just laws of logarithms. Another one, law of logarithm. Log alpha cancels everywhere, assuming that alpha is not equal to 1. And then, yeah, just multiply through by the product of all three of these. So log ax plus log ax squared, 2 log x squared, and 3 log x ax, right? That's log a plus log x, log a plus 2 log x, and so on. Hope I didn't make any arithmetic mistakes in expanding this and solving for the quadratic. But yeah, I mean, so this is what I get. There's two answers, depending on whether you take the plus sign or minus sign in that expression. I don't particularly see any step I've done here that can't be undone by just, saying these are equal and then going back up. So yeah, I'll say that that's my answer. It doesn't look like any of the terms would be, none of the terms in the original equation would be undefined or anything like that. So yeah, I'll just say that I think my arithmetic everywhere was correct, and it just came down to a question of manipulating that equation with some laws of logarithms and some simple algebra. If I think of anything that might come wrong, though, then I'll let you know. I'll put a highlight in the video somewhere. Thanks for the submission, and thanks for watching.